Hi, 8th grade. This is lesson 1 of module 8. So we're starting a new module. This lesson is construct scatter plots and examine association. And the I can statement says I can construct a scatter plot, determining whether an association is positive or negative, strong or weak, nonlinear or linear. I can recognize outliers and clusters. So there's a lot of vocabulary. You can see all the yellow here, scatter plot. So we'll talk about all that as we go along. If you have not already, pause the video here and go back and do the Spark Your Learning. That is related to this, and they're asking you to draw the graph of the information that they have that'll help you with these with the build understanding. So do that if you haven't done that already. All right, so let's look at the build understanding. So they give you a lot of vocabulary. So where you're learning about scatter plots. A scatter plot is a graph with points plotted to show a possible relationship between two sets of data. So hopefully these vocabulary words will make more sense as we use them and go through the lesson. So an association is the description of a relationship between two data sets. So that makes sense. These two data sets are associated in some way. It could either be a positive association when their data values increase together or decrease together. So the same thing is happening, either increase or decrease. So we'll also talk about a linear association, a nonlinear association, and a negative association if one set of data values increases while the other decreases. So this word outlier for a data set of an ordered pairs is a point that does not follow the overall pattern on a graph of the data set. So that'll kind of come into play later also. So what I'd like you to do now is pause the video here, go through and do the build understanding, and then we'll work on it together. Take some time and do it on your own first. All right, so let's look at this together. An association is the description of the relationship between two data sets. Two data sets have a positive association when their data values increase together or decrease together. So number 1, the graph of the data from Mrs. Tenney's class is shown in the scatter plot. So here's the graph. If you did the Spark Your Learning, then hopefully your graph looked something like this. So they're talking about study time versus test scores, and as the study time increases, what happens to the test scores. So they say, describe the change that you see in the graph. So what you can notice is as the study time increases, the test scores also increase. Test scores. So that would be a positive association because they're both increasing. As one increases, the other does as well. When data points lie roughly along a line, the data set displays a linear association. So we'll look at that. When the data set seems to follow a pattern resembling anything other than a line, the data set either displays a nonlinear association or no association. So that's important also, and we'll get to that on the next page actually. Do you think the relationship between test scores and study time appears linear? So one thing you can do is you can kind of look at it and see, could I kind of draw a line through a lot of the points, or most of the points, are they kind of following a straight line? So in this case, you can see that there is a linear association. This does kind of follow a line. I mean, there are a couple points that are a little bit off of what you would consider the line to be, but yes, they do appear to be linear. And there are different ways to phrase this, but the association appears to be linear. All right, so now we can look, two data sets have a negative association if one set of data values increases while the other decreases. So here, if we look at this graph, social media time compared to test scores, she does another study that she also tracked the number of hours students spent on social media sites and the scores they got on the test. So the data for this are shown in this scatter plot. So social media time is going up, test scores, what's happening there. So now you can see that as the social media time increases, you can kind of see the test scores are getting lower. The test score decreases, or test scores decrease. So do you think the relationship between test scores and social media time appears linear? To me, it looks like it does. These, you can kind of see, it doesn't have to be all the points on the same line, but you can kind of see that there is a linear association there. So yes, this association also appears linear. And we didn't explain the other one, but this one, as social media time increases, scores decrease. And that's kind of what we said in C. So that's A through D. So if you haven't already done E and F, pause the video and take some time and do those, and we'll look at those together. All right, so now we can look at this other vocabulary. Two data sets have no association when there is no relationship between their data values. Mrs. Tenney wanted to see if there was any relationship between the number of siblings that a student has and their score on the test. The data are shown in the scatter plot. And you can think about why she might think that siblings would make a difference or whatever. So think about that, and then we'll look at this. So E, describe the change in test scores that you see in the graph. So this graph looks a little bit different. There's not really a consistency here in the graph. So that's probably what you would say. There's really no association. There's no consistent line or change. So let's write something like that. There is no I mean, you could say, well, I can kind of draw a line here, but there's still like points all over the place. There's not really a cluster of points. And so F, do you think the relation between test scores and number of siblings appears linear? Not really. You could draw a line almost anywhere, and it's not really consistent. If you were to pick any 2 or 3 points to try to draw a line, there's still a lot of what you would call outliers. And so when there are that many outliers, they're not really outliers anymore. They're just sort of part of the data. So what you would say for this, and you can say it in a lot of different ways, any line drawn, any line I draw has too many, you could say too many outliers, or too many points that are far away from that line. So that's the build understanding. So go ahead and work on the rest of the lesson on your own, and we'll see you in lesson